Hello, everyone, and welcome to today's Fusion 360 Quick Start on Assemblies. We're right at the top of the hour. I still see some people signing in, so hang tight. We'll get started here in just a moment. Thank you. Hello, everyone, and welcome to today's Fusion 360 Quick Start on Assemblies. My name's Brad Tallis. I'm a Fusion Success team member, been with Autodesk almost 4 years now, over 24 years in the industry. I need to update my slide. I'm based in Colorado. My specialty is actually in direct modeling, and I just did a webinar on that yesterday. One of the things I love about Fusion, as-built joints. We're actually going to learn about these today. I think they're so cool. T-splines, built-in cam, pretty much everything inside of Fusion. I mentioned I'm a Fusion Success team member, and we're a group committed to making customers more productive with Fusion 360. I've got many experts on my team. I've got CAM specialists, industrial designers, mechanical engineers, etc. And we're here to help quickly close the knowledge gap while you start out with Fusion 360. And these webinars are one of those ways. So by the end of today's session, we should have a basic understanding of the difference between bodies and components. And I'll be honest, when I was first learning Fusion 360, this is what confused me the most. I just could not wrap my head around it. So I'm going to try to do my best to help you guys with that. We're going to learn about joints and as-built joints, motion links, contact sets, and motion studies. I mentioned I just did a webinar yesterday. I have a link in here, and this is a Sway document that I'm using, and I'll go ahead and share this document with all of you. This session is being recorded, so I will be sending a follow-up email with a link to that recording. I'll also include a link to this document. That way you have access to these live links. So for example, if I click on this one, here we are. We're in this Assemblies webinar right now. You'll see that there's a drawings deep dive, generative design, etc. I'm going to scroll down here. You can see we've got direct modeling, assemblies, sketching and part modeling, etc. So definitely recommend signing up for those webinars if you can. However, we do know that you can't always attend the webinars at the particular date and time that we offer them. So we do have them recorded, and you can click on this link and it will take you to our previously recorded stuff. So for example, here's the assemblies, direct modeling, sculpting, etc. Like I mentioned, this session is being recorded. I'll send out a follow-up email with a link to that recording. But as we're going through, please feel free to, to post any questions you might have into the Q&A section of Zoom webinar, and I'll try and answer them either live or right at the end, depending on the question. Okay, so we are going to be talking about just this menu right here, this assemble menu. Now, if you notice my screen looks slightly different, that's because I'm using the new user interface, and it's in preview right now. So if I go under my name, preferences, preview, you'll see this UI preview. And we're trying to improve the user interface. I really like it. I've been using it for the last couple months now. I highly recommend taking a look at it. So if my screen looks slightly different, that's why. There's no new commands, nothing different that you don't have that I do, or vice versa. So we're going to be talking about this assemble menu, and you'll notice that the very first command is new component. And if you've been using Fusion for any amount of time, you've heard the term bodies and you've heard the term components. And what's the difference? Well, basically the easiest way I can describe it is if you think your parts are going to have to interact with each other. For example, you've designed a desktop robot or whatever, and you've got the base and the arm and the elbow and the wrist and the grippers, and you got a bunch of bodies. You want them to interact with each other. they need to be components, okay? If you're gonna create a drawing of them, they need to be components. If you're doing just a one-off design, if you're just designing, a quick little clip to hold your sunglasses to your visor that you're going to 3D print or something like that, that can be a body because it's not really interacting with other parts or anything like that. But with that said, I would probably get used to trying to create everything as components, unless it's just a one-off design. But just get used to creating components. I'm going to show you why. There's some really cool benefits with it, okay? So I'm going to start out by making an assembly with bodies to kind of show you some of the drawbacks with it. So I'm just going to create a quick rectangle. I'm not worrying about dimensions or anything like that. So I'm just creating a block and I'm going to extrude this guy. Okay. And we can see I now have a bodies folder. And inside my bodies folder, we can see this little cylindrical icon that signifies it's a body. I can even rename this. Let's just call it block. Okay. Then I want to create another body. So I'm just going to say, okay, we'll extrude this guy. I'm going to go symmetric. And I'm going to say new body. In fact, you'll notice you see new component right here. But I'm going to go ahead and just say new body and watch what happens over in my bodies folder. When I say okay, I get a second body that appears. Let's just call this rod. Okay, so, really quickly, I was able to create these parts. However, they're bodies and not components. So if I want to try and move them, so I'm like clicking and dragging on them, you'll notice it's not letting me physically position them by just dragging them, which you can with components. The other thing is if I do want to move this block, I'm going to go ahead and say move. I'll lift up and let's just push it back a little bit. I'll say okay. And I was able to move that body. But watch what happens when I turn on my sketch. Notice where the sketch is at. It stayed in the same orientation, the same location where I created it. Now, this is a really simple example, but think of you've got 50 sketches and 70 parts or whatever, and you go to turn on one of these sketches and it's nowhere near the body anymore. It can get kind of confusing, especially for me. So this is one of the reasons I personally don't like using bodies. Now, I'm going to do the exact same thing, but this time I'm going to use components. So I'm going to start by saying new component. You'll notice I get this menu, and it looks like there's a lot to it, but honestly, all you really want to do is give it a name. So I'll call this block. You'll see that it's active. Okay, so when I say okay, we now see this icon right here, and it has this little radio button that says it's active. And if I open this up, you can see that it has its own origin. So here's kind of what I would call the world origin. And then this component has its own origin. Now I'm going to come in and create my sketch just like I did last time. I'll say rectangle. I'll throw another one on here somewhere. And notice I now have a sketches folder underneath my block component. And if I were to extrude this a certain distance, you'll see I now have a bodies folder underneath my block component. So you can almost think of a component as like an envelope of all of the information about that component, its origin, its sketches, its body, etc. Okay? So now I want to create the rod. So I'm going to come in here and say new component. I'll give it a name. I'll call it rod. Now this time I'm going to be a little bit more careful. You'll notice this says parent, and it says one selected. Well, right now block is selected. And if I were to say okay, basically rod would show up underneath the block as a child. You could think of that as the parent, and rod would be the child. Well, I want it to be at the same level, so I'm going to clear that off and select basically the top level and say okay. And now you can see how rod appeared basically underneath block and not inside of it. And this will make a little bit more sense. We're going to do another example here where we do a lot of nested sub-assemblies, etc. But I basically just said, create a new component, but make the top level be the parent. And notice what happened to my block. It turned kind of a transparent, okay? So I'll go ahead and do the exact same thing. I'll click on that front face, say create sketch. I'll say extrude. Let's just go symmetric. I'll say okay. And if I expand this open, you'll notice rod has its own origin, its own body, and its own sketches, just like block does, okay? Now, if I go up to the top level and activate that, you'll notice it's now, there's no ghosted effect or whatever. Okay, so now I'm gonna grab this rod and move it around. You can see I can this time because they're components. It's going to allow me to position them. Okay, but here's the coolest thing. Let's go ahead and move the block. So I'm going to say move up, move back. I'll say okay, and I'll turn on its sketch and notice where the sketch is. And hopefully that makes sense because, like I said, you can think of a component almost like an envelope of information. So if I say move the block, its origin had to move, its body had to move, and its sketches had to move with it. And I think this makes things so much easier to manage, especially in large, complex assemblies. Okay. Hopefully that makes sense. And again, I see a lot more people have signed in since I've started. If you have any questions, please feel free to post them out into the Q&A section of Zoom webinar. I'll try and answer them live or at the end. Okay, the other thing I like about using components is the timeline. Now, watch what happens when I activate block. Notice my timeline. It is only showing the steps that have to do with this active component right now. So we did a sketch and we did an extrude. I'll go ahead and let's just maybe fillet this edge like so. And now you see the fillet, okay? Watch what happens when I activate rod. You only see its sketch and its extrude. Maybe we'll go ahead and chamfer this edge. Say okay. Maybe we create another sketch on here and draw a notch in here or something like that for whatever reason. I'll say extrude, say okay. So now we see, let me go through all. Okay. We see the original sketch, the extrude, the chamfer, then another sketch, and an extrude. And maybe just to make things a little bit different, we'll put a small fillet on here also. Okay, so when I go back to my block, we only see the features that have to do with block. When I go to rod, we only see the features that have to do with rod. If I come up here and activate the top level, we'll see all of the steps, okay? And this can get confusing. Again, this is a simple example, but when you have multiple parts, multiple sketches, multiple features, that can get a little confusing. So when I come in here and say, okay, activate rod, I know these are only the features that have to do with rod. Okay, so Tim asked a really good question. Thanks for posting that out into the Q&A, Tim. He said, can you convert a body to a component or the other way around? And the answer is yes. So if I come back here, in fact, I'm going to undo. These are my bodies right here. You'll notice I have no components or anything like that. If I right mouse click on the bodies folder, you'll see it says create components from bodies. And watch what happens when I do that. Okay, my bodies folder goes away. My little round icons, my cylinder icons are now square, which means these are components. And if I activate that open, you can see that there's the origin and the body. However, you'll notice that the sketches don't go with it. So even if I came in and moved this guy back, the sketches unfortunately won't move with it. So that's the only drawback with doing that. However, and I think I know, Tim, why you asked this question. What if you accidentally start creating parts as bodies and you get halfway through and you're like, oh, I was supposed to be doing these as components. You're not hosed. You can still go ahead and turn them into components. And now, because they're components, I can move them around. And I could create joints with them. So you'll notice it's asking for components now. So I'm able to select my components. So yeah, great question. Thanks for asking that. Okay. Okay, one last thing with bodies and components. So I mentioned try and create everything as components. And you can even do what I would call top-down design. You don't even have to draw anything. So let me show you what I mean by that. I'm going to come in here. Let's say we're designing a bike. So I'm going to just say bike assembly. Okay. Then I'll say new component, and I know my bike assembly is going to have a front wheel assembly. So now you'll notice that front wheel is underneath my bike assembly. And notice the icon for bike assemblies changed now because it's a parent with a child. So you can kind of think this is the parent, and then the front wheel assembly is the child. I'm just going to keep doing this. We're going to have a rear wheel assembly. Rear wheel assembly. Now I want it to be a child of the bike assembly. So I'm going to click on that guy, say OK, and there's my rear wheel assembly. I can come in here and say in my rear wheel assembly, I'll have a wheel. Okay. I'll have the sprocket assembly. And again, I want to make sure that my sprocket assembly is under my rear wheel assembly. Okay. And then I might have a couple sprockets. So I'm just going to say sprocket 1, sprocket 2, and sprocket 3. So I'll say sprocket 2, again, selecting my sprocket assembly so it's at the same level. And then I'll do the same thing here. Oh, and actually let me show you a really cool trick. I should have shown this earlier. I've been clicking on here, typing in, sprocket 3, and then I'm having to, clear the parent and select that as the parent. Okay, that works. But I can also right click on sprocket assembly and say new component. And notice what it did. It didn't give me that window or anything like that. It just put a new component underneath that level. So now I can come in and we'll call that sprocket 3. So this is a really quick way. I could come over here and say new component, and you'll see it's at the same level, and I'll say tire. Okay, so it's just a really quick way of creating some new components without having to fill everything in. Okay, so now I have my sprocket assembly, and I've got these 3 sprockets. And now I'm ready to start drawing. So I'm going to activate sprocket 1. And I'll create something simple. I'm just going to do a cylinder as our sprocket. So there's sprocket 1. I'll activate sprocket 2. We can see that ghosts out. And I'll come in here and say, create a cylinder on that face of that previous sprocket. That looks good. So there's sprocket 2. I'll activate sprocket 3 and do the exact same thing. I'll say cylinder on that face. I'll make this one a little bit different just so it looks different. We'll extend it out a little bit. So there's my 3 sprockets. So I was able to create the structure of it ahead of time. And then I came back in and said, okay, let's activate sprocket 1. And we created our cylinder. And again, notice our simple timeline. I'll come in here and say, let's create a fillet. And it shows a fillet. We activate sprocket 2. It only shows the cylinder. Let's go ahead and throw a chamfer on here really quick. Hopefully this is making sense for you all. And then finally, sprocket 3, it shows just a cylinder. And we're gonna obviously make this a little bit more interesting. Let's put a notch in here or something. Again, I'm not worrying about dimensions or constraints or anything like that, just to speed things up. So I put in a notch. We're gonna fillet these corners here. like so. Maybe put a chamfer on these three edges, something like that, et cetera, et cetera. Okay, so notice the timeline for sprocket 3. Notice the timeline for sprocket 1. Notice the timeline for sprocket 2. Okay, very simple. I know I'm looking at this particular component, and these are the two features I have to do with it. Now, if I go to my top level and activate it, notice how lengthy my timeline is. It's actually showing me these were when I created my components. So we created a bunch of components. Then I did my 3 cylinders, and then I did a whole bunch of other stuff. And here's a neat tip. If you go under Inspect, Component Color Cycling, if you click on that, you'll notice that it kind of colors our objects some kind of like pastel colors. And if I look down at my timeline, I can see those same colors in my timeline. So I can see that like these 4 features have this yellow bar above it. So I know that those features have to do with that particular component. I also noticed it was created right here and back in here. Okay, so this is the cylinder feature that was used to create that. This was the fillet for the blue part, et cetera, et cetera. And you can see it even colors it over in your timeline. And this is a toggle, so you can turn it on or off. It doesn't change your appearance. If you had made these out of gold or wood or whatever, it does not change the appearance of them. So hopefully you find that useful. And hopefully this makes sense with components, okay? Again, if you think they're gonna have to interact with each other, they need to be components. If you're gonna create drawings of them, they need to be components. So unless it's a one-off design, I recommend getting used to creating components. If we have time at the end, I'll show you a really cool model I did way back in the day before I understood the difference between bodies and components, and you'll laugh at it. So hopefully we'll have enough time, I'll bring that up. Okay, so that was components. The next command is the joint command. And you'll notice J is the shortcut key for that. And it says positions components relative to one another. So in the old days, when you needed to position parts, you would use a term called like mate faces. So you would say, for example, mate that face with this face over here, and it would like slide the part over. I'm just like freestyling, so it's not going to be perfect. And it would basically align those up. And then you would say mate that face with this face down here, and it would like slide down like so. Again, just kind of freestyling. And then finally you would say, you know, mate that face with maybe this little face right here, and but you can see that's a lot of rotating, a lot of moving, a lot of positioning, all that kind of stuff. So we said there's got to be a better way, because basically when you were doing those mate faces, you were tying down the 6 degrees of freedom. So for example, this block can move left and right, up and down, and forward and back. Those are 3 degrees. And then it could rotate around any of these axes. And those are the other 3 degrees. So we said there's got to be an easier way. So what we do is we actually tie down all degrees of freedom and only open up the 1 or 2 that you might need. So for example, if I wanted this gray part to slide through this block, I don't want it to move up and down. I don't want it to move left or right. I don't want it to rotate in any direction. I only want it to slide forward and back. So we're going to tie down all degrees of freedom and maybe open up that 1 degree of freedom to allow it to slide. So I find Fusion's assemblies very easy to position parts and all that kind of stuff compared to some of the other CAD tools I've used. So I'm going to come in here and say joint. And you'll see it's allowing us to pick component 1 and component 2. So I'm going to get near this block right here, and you can kind of see as I hover over different faces, I kind of get different results depending on what I'm hovering over, okay? So you can see lots of little tick marks and diamonds and circles and all that kind of stuff. So what this is it's basically, it's asking for an origin. And you see that little coin icon kind of connected to my cursor? So what that's allowing me to do is, like, if I get near a corner or an endpoint, I can grab that corner. If I get near this diamond or triangle, it's going to catch a midpoint of an edge. So you can see all the midpoints of these edges. And then finally, the square is the center of that face. So you'll notice, same thing here. I get lots of endpoints, midpoints, and centers of the face right here. And this will make more sense as we go along, but I'm going to go ahead and just grab that upper right corner. I'm going to move over here, and I want to position it so it's right at this upper right corner. And watch what happens when I click. You'll see it kind of slide into position, and you saw it kind of wiggle a little bit. This is just kind of an animation showing what motion type it's doing. So you'll see by default it says rigid. So it's like we've glued, welded, press fit, or something into place to the green part. And if I say okay, I can no longer move this part around. It's rigid, it's glued, it's welded in place. I can move these other parts, no problem, but I can't move this one, okay? Now, I'm gonna undo. I'm gonna do that again. I've come up with a little trick or rhyme or whatever saying to help me out, because I always get asked, does it matter which part you click and in which order? And the answer is yes, okay? You'll notice I moved this block to this part. So I actually use this right here to help me remember which one do I want to move and where do I want to move it to, okay? So this is the one I want to move, and this is where I want to move it to. So that's how I remember, okay? So I'm going to say, this is the one I want to move, and I want to move it to over here. I'll say, okay. Now let's go ahead and do this rod. So I'm going to say, do the exact same thing. I'm going to say joint. Now, basically what I want to have it do is I want it to, for example, maybe I'll pick an edge and have that edge slide along maybe this edge in here, okay? So I'm going to get near this edge, and you'll notice that edges have an endpoint, a midpoint, and an endpoint. Doesn't matter which edge, even if they're tiny and short. You can see there's a start, mid, and an end. Okay, so in this case, I'm basically going to say, let's grab the middle of this line. So you can kind of see that coin kind of sliding along, and then it kind of snaps into place. I'm going to go ahead and click that point right there. And then I'm going to click the exact same point in here. So there's the line. I'm going to just grab this midpoint and watch what happens. It lined up the middle of this edge of the long part with the inside middle edge of the block. Now you'll notice it's shaking. It says, oh, it's rigid. And that's because it remembers the last motion type that you did. And the last motion type we did was a rigid. Well, I don't want it to be solid or rigid. I want it to slide. So I'm going to come down here to slider, and instantly it opens up that 1 degree of freedom. And you can see how it's animating what that would look like. I'll say okay. Now if I grab onto that part, you can see I can slide it back and forth. Doesn't matter if I move up and down, left or right, or draw circles. It doesn't matter. It's only allowing me to slide in that 1 degree of freedom. Now I have not set any limits or clash detection or anything like that, so you can see I can slide through, but don't worry, we'll fix that here in a moment. Okay. Again, if you have any questions or want me to repeat something or whatever, just let me know in the Q&A. I'm going to keep going here. Let's go ahead and do the gear. So I'm going to say joint, Now, again, I'm gonna kind of hover over faces and you can see we get different results. Notice when I do this guy, it finds all of the edges and centers of the gear, but I'm gonna get near this circle right here and you'll notice that the coin is kind of snapping to the center. So it's actually figuring out the axis of this edge and the plane of that edge that it's on. So we'll go ahead and just click there. This is the component. This is the one I want to move, and I want to move it to right here. So I'm going to click on this edge right here also, and you'll see it move over, but then you see an issue, okay? The animation is showing it sliding up and down. Well, I don't want it to slide, I want it to rotate. And again, Fusion remembers the last motion type that you did, which was a slider. I'm going to change this to revolute, and you'll notice it instantly updates and starts to rotate. Okay. So we turned off the degree of freedom for translation and we opened up the degree of freedom for revolution. You'll also notice that there's some arrows and some fields over here. So I basically twist up, that bottom edge part there with the top edge and here. And so it did, but I can also offset it a certain distance. So, let's just say it was right there. I could bring it up a little bit, a certain distance if I wanted to. Okay, but I'm not going to. I could also have it rotate to a certain angle if I wanted it to be at a certain angle. So I could say, like 45 degrees, for example. Excuse me. So now if I grab onto this gear, you can see that it only rotates. Okay, this guy only slides. Okay, let's take a look at this blue part, and you see that we've got these three bushings kind of floating out in space. So I'm going to go ahead and do just what I've been doing so far. I'll say, which one do I want to move? So I'll grab the edge of this white bushing. Where do I want to move it to? I want to move it to this blue part, but I'm going to zoom up and show you that I need to be careful because there's a small fillet right here. So there's a top edge and a bottom edge or an inside edge. So I want the top of my bushing here to line up with the top of the blue part. So I need to be a little bit careful, make sure I grab that top edge. Now you'll notice it remembered the last motion type was revolute, but in this case, we're going to assume these are press fit. So I'm going to just say rigid. You'll see it kind of shakes. When I say okay, if I move that blue part, the bushing has to move with it. Okay. I'm going to do the exact same thing here. I'm going to say joint. I'll click on that guy. I'll click on that guy. Say okay. And as I take a look at this, I'm like, that's kind of weird. Why is this one standing up a little bit taller than that one there? And if I look underneath, I can see, oh, I must have accidentally clicked that inside edge. And that's why I was pointing out earlier, you have to be a little bit careful. You'll notice I rushed on purpose. I purposely did this to show you how we can fix this. So by doing that, I accidentally clicked that inside edge. And let's pretend I've done a bunch of other things since then, so I can't just undo, okay? But you'll notice that every joint that we create has an icon. This one's kind of buried right there. But I can right click on it and say edit joint. Okay. Now I could measure the distance between these faces and move it down that particular distance or whatever. Okay. But we're not going to. Instead, we know that we put it in the wrong spot, which is the one we moved it to. So I'm going to go ahead and just clear component 2. And now I will come in and be a little bit more careful and making sure I'm grabbing that bottom edge. And we can see that component, sure enough, it lines it up, but it has that, let me set that to 0. But it's going the wrong way. Well, that's what this flip icon is for. I can just hit flip. You can see how we can flip it around. So I basically cleared the selection, reselected the correct edge, and it came into position, but then it was upside down. So I just hit flip and say, okay. And oops, there we go. It's now in the correct location. Okay, so lastly, I'm going to do this red bushing. I'm going to do the exact same thing. Top edge, making sure I grab the top edge. It's rigid. I'm happy with it. Okay. But when I look at it from the front, I notice that the red is sticking out below the blue part. Well, why is that? I lined everything up perfectly on the top face. So that must mean that the red part is actually taller or thicker than the blue part. Well, I want it to be equally spaced. So here's another neat little tip. I'm going to say joint. And instead of picking this top edge, I'm going to hover over a cylindrical face. And you can see it has a top, a middle, and a bottom. Well, same thing with this cylinder. It has a top, a middle, and a bottom. So I could come in here and say, grab the middle of that guy and position it on the middle of this guy. And now when we look at it, we can see that we have equal spacing because it lined up the middle of those cylinders. Okay. Now I'm going to do that again and slow down and show you some tips on how I did that. Okay, so I'm going to say joint. Now you'll notice when I get over here, it's trying to catch to edges and faces and cylinders. You see a lot of flashing going on, and it's kind of hard to grab that middle point very easily. So I want to control my selection. So what I'm going to do is I'm going to hover over a cylindrical face, either the inside or the outside, and hold down my control key. And now I'm controlling my selection. You'll notice it's no longer looking for edges or other faces or anything like that. As soon as I let go of my control key, I'm back to here, okay? So all I have to do is get near a cylindrical face, hold down my control key, and it's no longer trying to catch to all those other edges and faces. So now I can basically just move up and down and grab that middle guy. Same thing over here, lots of faces and cylinders and other faces and all that kind of stuff. All I have to do is get near my cylinder, hold down my control key, and now you'll notice it's not selecting any other stuff. So I'll just hit the middle guy there and say, okay. There we go. Okay. If I move this blue part, all of those parts move with it. So now all I need to do is position this in place. So I'm going to say joint, and I'm going to grab the, making sure I grab that bottom edge, the cylindrical bottom edge, because I want to line that up with the cylinder and this guy right here. Now, again, I have to be a little bit careful. There's a chamfer, so I'm going to grab that top edge. And a couple things happen, okay? I'm going to pause here for a second. You'll notice, first of all, that the bushings that we just put in here didn't move. And this freaks people out. And the reason for that is right here. We're only dealing with two components at a time. Which one did we want to move? We wanted to move the blue part. Where did we want to move it to? We wanted to move it to the gray part. Okay. As soon as I say okay, those bushings know that they have to be rigid with the blue part, so they'll update and move correctly. Okay. So don't freak out when you see that happen. As soon as you say okay, everything's going to work. Okay, now I want to do the same thing again. The other thing I noticed is when I positioned it, it kind of was a rigid. Well, I want it to be a revolute. So I'm going to say revolute, and you'll see it slicing through the object. Okay, again, it's just a quick animation to show it's revolving around the axis that I picked. But of course, it's going to cut through the model. So don't worry about that either. Okay. But probably the most important thing is if I look at this from the side, again, I have an issue. We can see that this gray part is thinner than the opening of the blue part. So how do we fix that? Well, let me undo back so we can get back here so you can kind of see what's going on. Just like in the red example, I could grab the middle of a cylinder. However, there is no middle over here. There's no middle of a cylinder. So I have nothing to catch to come over here. So we have a cool command called between two faces. So watch what I do here. I'm going to say joint, and then I'm going to right mouse click. And we can see the command right here. Now, again, personal preference, my little soapbox, I wish this command was in the joint command window. I'm not sure why it's not, but I think it's because you can use it in other areas. So you just have to remember to right mouse click and say between two faces. Then I'm going to select that face there. I don't even have to rotate. Okay, it knows I'm probably be asking for a planar face. So I'm going to click on that face there. Okay. Now watch, let me kind of rotate here. Watch what happens when I hover over the circular edge. You can, oops, you can see that tan plane or orange or whatever color floating in between those two faces. And we can see the origin. Wow, I'm not sure why that's not working. Right there, okay? So it's basically finding the center of this circle and projecting it between these two faces onto that plane. So I'm going to grab that guy there and the center of this cylinder, that guy there. And if we look at it from the side, sure enough, we can see that we have equal spacing. Okay, so I'm going to do that again because I know that was a lot of talking and a lot of clicking. It's only really one more step, honestly. Joint, right mouse click between two faces. I'll select the two faces, and then I just have to hover over like a cylindrical edge or circular edge or whatever, and we can see there's that origin point. So I'm just going to go ahead and click on it. Come over here. So it found the center between those two faces. So I want to do the same thing here. I want to find the center between this cylinder here. So I'm going to grab that guy. Make sure it's revolute and say okay. And we can see, sure enough, that worked. There's some clashing going on, but it brought the arm in place. And now if I grab this arm, I can rotate it, but you can see how the slider is kind of affecting it also. We can kind of start to see, how's this thing going to work? Okay. Okay, so now the last thing I need to do is to connect the blue part to my gear, but I'm actually missing a component. I don't have that pin that's necessary to physically connect these together. Well, the good news is you don't have to. You can actually create joints between parts, and they don't have to have a physical part to connect them. So let's go ahead and do this. I'm going to say joint. Now I'm going to purposely make a major mistake here. I'm going to say, grab the top of this red part. This is the one I want to move. Where do I want to move it to? I want to move it to the top of this gear. And you'll notice that sure enough, it moves it, but I get this warning. The selected joint type would result in a conflict. So what does that mean? Well, physically, you couldn't do this, right? It would cut into it. But what's really it's complaining about is it says, hey, that red part needs to stay up here, but so I can't go down there. But I want to have it be able to revolve in here. So basically what I need is a revolute and a slider. That way it could slide up and down to get to the correct position. So that's where we're going to open up 2 degrees of freedom. So we have an option in here called cylindrical. Now, it's going to be kind of hard to see what it's doing here, but you can see it's sliding up and down and it's rotating at the same time. And when I say okay, see what happened? It lined up axially, so it's lined up on the correct axis. And because we added the slider option in there, it was able to slide up to stay where it needed to be with this blue part. And now if I grab the gear and crank it around, we can see that sure enough, that simulates. This is part of a handheld saw where the blade will move forward and back or whatever. So the motor drives this gear, and we can kind of simulate how that would move forward and back. Okay. Hopefully that made sense. Now, I'm not going to show every single option in here. We did rigid, revolute, slider, and cylindrical. We also have pin slot, and it's basically exactly what it says. It allows you to create a joint like a pin that goes into a slot, and that slot could be angled or curved or whatever. Planar, you can kind of think of as like a hockey puck on ice. So it can move in like the X and Y, but you don't want it to move in the Z. And then ball is kind of a cool joint type where it opens up all 3 degrees of rotation, but locks down all 3 degrees of translation. So like a ball joint, like a tripod head or something like that. Okay. Okay, so that is the joint command. Now, I'm going to, let's go ahead and create the pin that needs to go in here. So I'm going to say new component. I'll call it pin. Okay. And let's just sketch on that component there. And I'm going to extrude. So I'm going to extrude up a little bit, and I'm going to extrude down a certain distance. Now, here's another trick, has nothing to do with assemblies or joints. I want it to extrude down to the bottom of the gear, but I have no idea how far that is. All I have to do is click and hold for about a second, and you can see that it's going to probe through. It's like a laser. So this face is that cylindrical face. Then the next one is the bottom of the gear. The next one is the bottom, the inside bottom of the green part, and the outside bottom of the green part. So I just clicked and held my mouse for about a second, and I'm going to select that guy there, and notice how that jumped down. It's now the same thickness as the gear. Didn't have to turn off any parts or anything like that. I'll say okay, and I now have this pin. Okay. Now I want to work on this, and there's a lot of stuff in the way. So I'm going to right mouse click and say isolate. Okay. Timeline, a sketch and an extrude. Well, because it's a pin, we want to put a slight chamfer on there. So let's just do maybe 0.5 in this case. I'll say okay. There's my chamfer. Now I'm done with my pin. I'll right mouse click and say unisolate. And it's just a really quick way to be able to work just on the pin and not worry about all the other stuff. Okay, I'm going to go ahead and activate my top level assembly. I've created this pin. It's great. But I go to rotate my gear and the pin stays put. Why is that? Well, we haven't created a joint type. It doesn't know that it's supposed to move or stay put or whatever. So this is where as built joint comes into play. If the part is where it needs to be, I can come in here and say as built joint, and let's just make it rigid. And it says, what are the components? Well, I want this pin to move wherever that red part goes. I say, okay, and boom, we're done. It's literally that quick. Okay. Let me undo back a couple steps. So it's free again. We don't have a joint type. If I were to use the regular joint, it's asking for like an edge or a center or something like that. Well, this center doesn't line up with the center of this. This edge here doesn't line up with the edge here, for example. You'll see it'll move down. Let me go rigid. So I'd have to know how far back up to move it and all that kind of stuff. So this is where as-built joints are so powerful. Um, oops, let me go ahead and redo that. I can just come in here and say as-built joint. That guy, let's do the blue guy this time. Say okay. Now when I drag the gear, it moves. Let's take that to the next level. Check this out. I'm going to insert a McMaster car component. It could be something off of GrabCAD. It could be something off of somebody's web page. It doesn't matter. I'm going to do a search for toggle clamps because I have a CNC machine that I use toggle clamps on, and I want to know like how tall this handle is, what my overall clearance is going to be. So I'm just going to go ahead and pick one of these. And let's just download it as like a step file. When I hit save, it's actually going to physically bring this into my session. Okay, it takes a couple moments, but you'll see there it is. I'll say okay. And I'm going to convert all of these bodies into components because like right now I can move the whole thing, but I can't move them individually. So I'm going to right click on bodies, and this is related to Tim's question he asked earlier. I'm going to say create components from bodies, and notice what happened. No longer have any bodies folders, but now these are individual components that I can move. However, they're assembled in the correct location. So we're going to be able to use as-built joints because it's already built correctly. Now, the one thing I haven't shown yet is, for example, if I come back to this guy, if I try and move this green part, you'll notice I physically can't move it. I can move the other parts, but I can't move the green part. Why is that? Well, you'll notice it has a little pin icon right next to my cursor. It's hard to see, but there's a little pin icon. That means it's been grounded. And basically at the top of the menu, let me go ahead and unground it. There's no pin. Okay. Now I can grab this green part and move it around, but you'll notice everything moves with it. And if I were to try and rotate the gear, I can't because it doesn't know what's supposed to stay put. So we have to ground something. It's kind of like we're going to hold this part in our hand, or it's going to be attached to a table or whatever. Something has to be stationary. So I'm going to right click on gear housing and say ground. It puts that little pin icon. Now I can't move the green part, but everything interacts with the green part now. So I have to do the same thing over here. I'm going to say that this part here is going to be bolted to the CNC machine. So I can see that's component 2. So I'm going to right mouse click and say ground. Now I physically can't move that part. We've grounded it in place. But now we can use as-built joint. So I'm going to come in here and say as-built joint. And a lot of these are rotational. So I'm going to come in here and say revolute. What are the components? Well, I know this guy and this guy. And now you'll notice it's asking for a position. What's it going to rotate around? All I have to do is get near like an edge or a face that would define that and click, and we can see that it's going to revolve around that pin. I didn't have to move it from space and zoom in and rotate or whatever. In fact, I'll do that again. I'll say as built joint. I know that this guy and this guy are going to revolve around like that edge there. I know this guy and this guy are going to revolve around like that pin there. And I know that this arm and this bracket are going to revolve around that guy there. Okay, now when I grab this handle, we can physically see how those would interact with each other. But we also see a couple issues. First of all, the rubber grip at the top isn't moving. So in the assemble menu, there's a command called rigid group. Very useful. Instead of like saying that this handle is attached to this metal part here, with some kind of a joint, we're just saying, hey, these guys have to move together. I'll say okay. And now when I move the metal part, the handle moves with it. It doesn't matter which one I grab. Same thing with this. You can almost think of this as like a sub-assembly. These are a whole bunch of individual components, right? Well, I want them to kind of move together. So I'm going to say rigid group. And let's just select all of these guys. Say okay. And now if I move one, they all move together. In fact, I could kind of say that this needs to be able to slide. So I'm going to say as built joint. I'll say slider, that part and that part. And I want it to slide maybe along like this edge right here. Now it's just giving me a preview of a single component, but as soon as I say okay, and I grab any of those, you can see how it's going to slide through that groove all together. And if I grab the handle, we can simulate how this whole thing would work. Now, this could have been created in SolidWorks. It could have been created in Inventor or whatever. It doesn't matter, but I'm able to work with it just like I created it myself inside of Fusion. Okay. Now, I'm going to show you something we're going to come back to this in a moment. You'll notice there's a mechanical stop right here. But as I drag, I can physically go past that and even do some weird stuff like, physically impossible, right? Well, we're going to actually learn about a command that will solve that. Okay, so we've talked about components, joints, as-built joints, rigid groups. I'm going to skip over joint origin because you've already seen it. It's basically this, little coin that allows you to specify which point you want. And it shows up when you create a joint, so there's really nothing to learn here. So I'm going to skip that guy. Then we're going to learn about driving joints and motion links. So I'm going to go to another assembly here. And by the way, please do not let me forget, I'm going to show you where you have access to this assembly here and this assembly here, okay, at the end of the video. That way, or at the end of the session. That way, you can rewatch the video. You can just scrub to the end to kind of see where the location is because it's kind of buried a little bit. So don't let me forget to show you that because I always forget. Okay, so here I've got a vise, and you'll notice that it has, this slider here with some soft jaws, etc. But you'll notice I can go past, and I'm kind of clashing. And we also have this really cool handle that rotates this, threaded rod here. But you think it would look better if they interacted with each other. So that is what motion link does, okay? Drive joints allows you to be very specific. I'm going to do the motion link here in just a second. As I'm dragging to the left, I'm just randomly dragging. Who knows how far that's going, okay? But if I came in here and said drive joints, and it's kind of hard to see, but my slider joint is kind of tucked down in here. I'm going to click right there. I'm going to say go exactly 1 inch. You'll notice that it did the slider exactly 1 inch. Okay. Or I could say, let's pick the rotational joint and let's go exactly 12 degrees or something. Let me see. Try 90. There we go. So there's 90 degrees. Let's try 180. So you can see how it's rotating the handle exactly to 180 degrees. So it's a way to tell it to go a very specific distance. That's what drive joints is for. Okay. Now I'm going to do motion link. What motion links allow you to do is to link two joint types together. So for example, when you see it says joints, I'm going to say I want the slider and the revolute joint to be linked together. So now you can see for every 360 degrees that this rotates, slide the slider 0.394 inches. So now when I grab this handle and I start to rotate, you can see how it's simulating how that slider would move, okay? So as I crank that around, or I could grab the slider and drag it and it rotates the handle. So this is a really good way to simulate, for example, if you had a small gear and a large gear, you'd have two revolute joints and you would motion link them together and you would say for every revolution that the small gear goes, the large gear only goes a quarter of that, for example. Now what's neat is I can come in and I can edit that. Let me just edit this motion link. And we were saying for every 360 degrees, go about 0.4 inches. Let's go about 0.04 inches. So now watch, as I crank, you're gonna see it barely slide. So I'm having to crank this many, many times to get the slider to go, okay? So you do have control over that ratio, okay? So I'm gonna put that back. And you can reverse the direction in case, the gears are turning the wrong way or whatever, you can do that. But now we're back. Okay. Another thing I want to show you are joint limits. Like I showed here, previously this guy was like cutting into the body and all that kind of stuff because we hadn't set any limits. So we're going to learn about setting limits here. So I'm going to drag this guy to the left and we can see that sure enough, it's clashing. So we want it to not do that, obviously. So I'm going to select my slider, right mouse click, and say Edit Joint Limits. And we have a minimum and a maximum. I'm going to activate the maximum. Let's just say we want our maximum to be 1. And now here's something I, again, don't like about this is it's only dealing with, basically this one component. So you see the soft jaw doesn't move with it. But as soon as I say OK, it resets. I'll go ahead and drag to the left. And now you can see, even though I'm still dragging to the left, it can't go any further because we've set the limit to only go 1 inch in that direction. Now I could take a measurement between these 2 points right here and add that to my 1 inch, but I'm going to show you a way better way. Let's go this way and you can see, oh, we're clashing. So let's go ahead and edit the minimum. Let's just say maybe let's go minus 0.25. That looks pretty good. It's almost lined up. So now I can go only that far to the left and only that far to the right. So you can kind of see we've set our limits. And you can do this with rotational limits. Like I mentioned previously, let's say you designed a desktop robot. Maybe you only want to limit the base to rotate 180 degrees so it doesn't wind all the cables around itself, right? So you would set your rotational limit to 0 to 180. Okay. Now I mentioned there's a way cooler way. Check this out. I'm going to edit my joint limits and turn these off. So we're back to clashing in both directions. Okay. There is a command in here called contact sets. Now, be careful, okay? And I'll show you why here in a moment. We do have an option here called enable all contact. If I were to turn that on right now, it's going to live calculate constantly if objects are clashing or touching each other or intersecting and all that kind of stuff. So the fact that all of these threads are on here, it would probably bring Fusion to its knees. So I would not want to enable all contact in this example. However, I'm going to say enable contact sets. And you kind of have to say, turn the switch on. So I'm going to say enable contact sets. Then I'm going to come back in here and you'll see now new contact set. So we said, we're gonna analyze. Now let's go ahead and analyze. So I'm gonna say new contact set, the bodies or the components. I wanna see when that soft jaw touches that soft jaw. I'll say okay. And check this out. Drag to the right, I can clash. I drag to the left, watch what happens. As I get closer, it kind of slows down. You can kind of see slow down, but I'm still moving to the left, and it no longer moves. It sensed when it was touching. Okay, so let me do that again. I'll drag to the left, and you can kind of see, kind of watch the handle back here. It's kind of interesting. You'll see it sort of slow down. I don't know how well it shares over the, you kind of see it rotate just a couple more degrees as it's calculating, and there it is done. Okay. Now I'm going to use drive joints. I'll click on my slider joint, and it says where it's at right now, it's at a distance of 1.219 inches. So I'm going to copy that. Okay. Then I can use that as my maximum joint limit. I had said it was 1, so I was off. I'm going to go ahead and paste in 1.219. Okay. Then I'll do the exact same thing again. I'm going to say new contact set, this guy, and maybe this guy. I want to make sure they don't hit. So I'll say okay. I'll drag to the right. You can see it slow down, and then I keep dragging to the right, keep dragging, nothing. So it's sensed when it hit. And I'll do the exact same thing again. I'll say drive joints. I'll click on the slider, and it says it's minus 0.906. So I'll copy that guy and edit my joint limits. So my minimum I said was minus 0.25, but in reality it's minus 0.9. So I was off a significant amount. But now I'm telling this slider joint what its limits are. So I no longer need to check for contacts. I'm going to say disable contact. But watch what happens. I drag to the left, it stops. I drag to the right, it stops. So I was able to physically figure out how far can this machine move. And you'll notice it's much faster because it's not doing that live calculation. So let's go back to our this guy here. Enable contact sets. New contact set. I want to know when that arm hits that pin. I'll say okay. We'll drag the handle back, and there it is. That is physically how far it can rotate. And now I can take measurements. I know how tall my gantry needs to be for clearance. I know how wide my gantry needs to be for clearance or whatever. So really cool that I can actually simulate how this physically would work. Okay. Now here's another example. This piece here is cutting into that piece there. So I could come in and say, new contact set, that guy and that guy. Say okay. Still rotate to the right and rotate to the left, and I can see I can only go that far. You can kind of see physically won't let it go any further. So cool little trick there. Okay, now the next one is enable all contact. And I said, be very, very careful with this. I would only do this on simple assemblies with not lots of faces like threads and stuff like that. But what's neat about this is you don't have to have any joints like you do with contact sets, okay? So for example, I had, all these rotational joints already set up. I had, all of these slider joints set up. But with this, I actually have 0 joints whatsoever. You don't even see a joints folder over here. So basically, it's a bunch of green rods kind of floating inside of these red bands. So I'm going to come in here and say enable all contact. Okay. And that's, oops, didn't mean to click. That's basically it. So you'll notice it says disable contact. So what I'm going to do now is I'm just going to grab one of these green rods. And when I start to drag to the right, watch what happens. It actually calculates, okay, I'm hitting that red band, so it's going to pull that red band along. Then that's going to pull the green, which is going to pull another band, which is going to pull another band. Okay. If I grab this guy here and drag to the left, you'll see it's going to kind of rotate those bands around and start pulling them together and stuff like that. Okay. Now, you'll notice I'm going fairly slow. If I go too fast, it can't mathematically calculate fast enough. And you can see I pulled that rod. If I go slow, it works great. Okay. But if I go fast, it can't calculate fast enough. Okay. So be careful with stuff like this. But I can even grab, for example, this red band and start pulling on it. You can kind of see how it's going to affect things. So this is kind of a cool way. For example, I helped a customer out. They designed the reclining seats in airplanes. And you can kind of think of like almost like an S-curved garage door track, maybe. And so we simulated how much slop the wheels have in the track. And, we could say drive joints when it's at 45 degrees, what angle is the footrest at, and all this kind of stuff. But we ended up using contact sets to do that. Okay. Another neat example is if I had two spheres. We just put a large sphere, trying to cut into it, and a small sphere. And I want those to be tangent with each other. I want this touching that one. Well, I might come in here. Let's create components. I'm going to go ahead and ground this guy. And then I'm just going to do a new contact set, that and that. Say, okay. I'm just going to drag this to the left. And you can see now that sphere is touching that other sphere. So it's tangent to it. So it's just another little trick on how to get a sphere really quickly in place. Okay, moving on here. Let me just kind of clean some of this up. Okay, so as I've been going through, and for example, as I rotate, maybe you've noticed I've been coming up to this menu up here, and it says capture position or it says revert, and I've been going back to revert. And what that does is notice where it is. I rotate, I hit revert, it just puts it back. I can go way far away, hit revert, and it puts it back. I use revert quite a bit, but I also have the ability to capture the position. And what that's going to do is actually in my timeline, it's going to capture that position in time right there. Okay, you want to do that? Well, you can almost think of it as like a configuration. So for example, let's say you've designed a fire engine and you want to show it, like driving down the highway. So the extension ladder is inside, the extension arms, the support arms are closed in. You could capture that position. Okay, then you could extend the ladder. I'm just going to use this as an example. So now that ladder is extended, I could come in and capture that position. So now you'll notice I have two positions in time. And I can go back to the driving down the highway where the ladder's fully enclosed, or I can go to the show it on the site with the ladder fully extended. And I can capture as many positions as I want, and I can suppress them, I can activate them, etc. So I should probably design a fire truck to actually show my example. But hopefully you see the idea there. Okay. Driving down the highway and on site fully extended. You can even use that to help you with your design. So for example, I've got this box cutter and in here I've got this slider joint that, extends the blade out. But I'm obviously missing a slot in the body for this thumb switch or whatever you want to call it. So I want to actually use the physical distance that it can go. So you can see we got some limits set. So it can't go any further than that. It can't go back any further than that. So I want to use those. So I'm just going to go ahead and let's just create a sketch. And I'm going to project this circle and say, okay, and stop my sketch. And I'm going to slide this guy forward and capture that position in time. And so you can see there it captured it in time. I'll create another sketch. There you can see the original circle. Let's go ahead and project that guy. Say okay. And maybe create a quick slot. I'll just do a center to center slot. So let's go from here to here, something like that. I'm not going to worry about dimensions. Okay. Turn on my sketches. I'll grab my profiles here and say extrude. I'm just going to cut through the body. Now, if you're keen-eyed, you'll notice that it's actually physically cutting through the switch. This doesn't have to do with assemblies, but a neat little trick here. I'm going to say objects to cut, and we can see that it's cutting through the blade cradle. I don't want it to do that. I only want it to cut through the left body. I'll say okay, and I now have a slot that's the exact distance that this needs to slide forward and back. Okay, so I was able to kind of capture this position in time, use it, capture this position in time, use it, and then create the slot using those. So that's kind of a cool little trick. Okay, the last command in here is motion study. So I'm going to come in here and let's just use this guy here. So I'm going to say motion study. And basically what this is it allows you to analyze your design. I'm going to make this a little bigger through time. So we can see we have 0 to 100 right here. I can slide this back and forth. And then we also, you see it says select joints to animate. I'm going to go ahead and pick on this rotational joint. And we can see this line up here. So I'm going to say maybe at frame 40, I want that to be at minus 12 degrees. Okay, so you can see it's going to go from, let me just drag over here. It's going to go from about 40 degrees, and it's going to rotate to minus 12 degrees. Okay, and then maybe at frame 50, I want that to be a positive 20 degrees. And then, sorry, not sure why that showed up. I'll come over here again, and let's go maybe minus, I don't know, 30 degrees. Okay, so, and then I can go at the very end and make that, let's go back to 12 or something. Okay, so what this basically allows me to do is I can kind of scrub through and analyze how this is going to work. So I can force it to go to certain angles or distances or rotations, and I can analyze how that would physically work. So I have a couple options here. I can hit play, and it's going to play through. And again, I don't know how well this is going to share. I'll go ahead and hit play again. So I have these modes: play once, play forward and back, which I call ping pong. So basically it just goes back and forth. Okay. I can change the speed. Just slow it way down, speed it way up. Let's go ahead and slow it down a little bit. And you'll notice it's taking a long time to rotate, and then it goes really fast right there because it's a shorter distance of time. Okay. I can also loop it, so it just loops. Let me just speed that up a little bit more. So you can kind of see it just keeps going over and over and over again. But what I usually use it for is like, I can scrub along and I can see the angle right here, the value is at 6 degrees. So I keep going, I'm getting closer and closer to 0. So there's 1, and there's minus 0.3. So I know around the 30 mark is where it's actually crossing the 0 line. Same thing here, -5, -2, and then 0.8. So I kind of know where it's actually crossing that 0 line, for example. Now, unfortunately, this is not the best example because you can actually add in other joint types. So I could add that guy in there, and we can see that it's a slider, okay? But you'll notice that if I were to click somewhere and say, okay, make that -6, it's going to bind everything up. It physically can't move. And now if I drag, you'll see how it binds up. But we can visually see the two numbers now as I'm moving along. So again, a better example would be like that desktop robot that I was talking about. As the base rotates, maybe the elbow rotates, maybe the wrist is rotated. I can analyze all of those and see how they interact with each other. So that's kind of a high level overview of motion study. Okay, that is it. I have about 10 minutes left, 9 minutes left. If you have any questions, please feel free to post them into the Q&A really quick. As you're doing that, I will go find that assembly I was telling you about, which I shouldn't show you because I'd be embarrassed about it. But you'll see why using components and bodies are going to be so useful, or using components instead of bodies would be so useful. And it's a fairly large assembly, so it's going to take a while to load. So again, if you have any questions, throw them into the Q&A or the chat window, and I'll answer those. So here is, a remote control radio unit that I worked on, okay? But look at my timeline. It goes on forever. I've got errors, I've got warnings. I mean, I'm continuing to slide. It goes on and on and on and on and on. And so to figure out like which sketch was used to create which button or whatever, it would take forever to be able to do that. But if I come in here to my gimbal housing, in fact, you can kind of see I've turned them into components after a while. So they don't have any structure in them except for when I moved them. So I should have, made them as individual components, but instead I get this thing, okay, with the very complex timeline to the point where I haven't even finished it yet. I need to finish the back and all that kind of stuff, but I probably should start over and do it the right way, honestly. Okay. I don't see any questions. So again, I appreciate everybody's attendance. I'm going to do one more quick little plug. I've started doing some live streams out on YouTube. So if you just go out to YouTube and do a search for my name, Fusion 360, you'll find a bunch of live streams, and I do them every Tuesday and Thursday. Basically focus on topics that are important to everybody, such as like sculpting basics, learning about construction planes, sheet metal, etc. And then sometimes I'll do, for example, drawings. I'll do something like just creating a sample part. Like, how would you go about creating this particular part? Okay. And I walk through step by step, using the mirror command, et cetera, et cetera. So highly recommend signing up for those, subscribe. It's another way to learn the product. So with that, I want to thank you for your attendance. Keep an eye out for a follow-up email with a link to the recording, and I hope you have a good rest of your day. Thank you. Thanks, David. Thanks, Paul. I appreciate that.